what's been like a top thing on your mind that you would love to dig your teeth into and start talking about?
I want to talk about the transactions versus durable executions. Right?
Okay,
Because the
yeah.
durable executions, they have been dubbed as the new transactional stack, right? So um, that basically means that the term transaction was used as a like defining characteristic of durable executions, right? So there had to be some similarity, something that triggered that idea that database transactions or that durable executions are akin to database transactions, right? So what durable execution is for a distributed system, a transaction is for a database, right? So that's basically what that term, the new transactional stack, like implies. Right? But then it's super interesting to look into it, like what is the difference between transactions and durable executions in terms of like guarantee? What can they provide? So first one
Where do people get hung up?
is like let's look at what a transaction and a durable executions what they are, right? So it's like you can argue both of them is a sequence of operations, right? A transaction is a sequence of operations, and the durable execution is a sequence of operations, right? So they have a very they're very similar in nature. Now, a transaction formally is a sequence of operations that end in exactly one commit or exactly one abort. Right? If the transaction ends in exactly one commit, it is as if the transaction has executed to completion in isolation, right? And if it ends in one abort, it is as it not executed at all. And for durable executions, we don't really have that. We don't really have that like equivalent. You can still argue though, because especially for resonate, durable execution is just a normal function. You can still argue that it's a sequence of operations, right? Other function calls, whatever you do in that function. And it ends in a terminate, right? And a terminate can either be a successful termination or an unsuccessful termination, raises an exception. But there is also the possibility of a crash. So that is true for both a transaction and a durable execution. When a transaction, when the database crashes in the middle of a transaction, right, we treat it as if it was aborted. And but for durable executions, that's a little bit more difficult. And then we can get into why in a moment. But so that's basically sequence of operations, right? So,
Can I
but
ask you?
let's look. Hmm?
Can I ask you? And I don't mean to interrupt
Mhm.
that train of thought specific, but you were, I feel like, one of the voices that helped focus in on the term durable execution as the like term to describe the new abstraction that is coming onto the market in in terms of in the distributed systems industry, right? What like what and I know you're not like one to throw around terms so much. So like there's obviously like some criteria in place that you sort of focused on to like determine that that was a good term and that there were some boundaries in its definition, if that makes sense.
So for the durable execution, um, I did look at some of their like core characteristics, right? And that durability of progress, right? So that in the loosest sense possible, that progress is persistent, right? Progress is durable. Um, is a defining characteristic of the durable executions. That's why I honed in on that particular term. I also previously did liken durable executions are to distributed systems what database transactions are to databases.
Yeah.
And there is a very specific reason for that one. So it's like much more than just like hopping on to one of the defining characteristics of durable executions. It's like, why do I make that comparison? Database transactions are one of the most successful abstractions the software engineering ecosystem has ever introduced. Right? There are some abstractions that are just beyond incredible. If you look at operating systems, processes, for example, right? The process, it gives you the illusion. It gives you an illusion equals developer experience here. It gives you the developer experience that your application owns the CPU. Together with virtual memory, right? It owns the CPU and the memory in the machine. Even though there are other processes that are also on that CPU and on that memory, right? It's an absolutely fantastic developer experience. The transactions similarly successful, whereas you can argue, arguably, right? So it's a matter of taste somewhat, but even more incredible developer experience. And that developer experience that can be like captured as happy-go-lucky, worry-free, right? As soon as you cross that threshold from your code to begin transaction, right? It's like, oh my God, worry-free. Yeah? It's like all stress is gone. You basically just have the guarantee of correctness. All right, that's don't worry about it. We'll fix it. We gotcha. Yeah? That's what a database transaction is. We often classify it or describe it in terms of ACID, which is, by the way, an absolutely fantastic term and acronym, because it has taken over the entire ecosystem, right? And everybody describes what is a transaction in terms of ACID, like atomicity, consistency, isolation, and durability. But I think it somehow doesn't do it justice, because it doesn't capture that like developer experience, that feeling, right? Cross the threshold of begin transaction and you are guaranteed correctness, right? So that is absolutely amazing. And so why did I then link the term transaction to like durable execution?
Yeah,
it's because we want to provide you a similar developer experience, right? Whereas like worry-free, just like we gotcha back, yeah. But the transactions, yeah. Oh, I'm sorry, I didn't want to interrupt.
Oh no, but as we've talked about, right? Like we have since discovered that like there's so much more nuance there, right? There's like,
oh yeah,
there's way more caveats and or assumptions you have to make for that to be true, right?
Yes. Yeah. That's really that's a big one. All right, so it's like database transactions are in a position to make a lot of guarantees and actually not asking for much or anything in return. They just give you that guarantee. Oh, but durable executions, distributed systems, they ask for so much. And you cannot abstract it away. Distribution is an irreducible property. You cannot pretend that a system is not a distributed system. So, and let's look into why, right? Why is that the case? So one of these prerequisite, you can say, to correctness is completion, right? You got to run to completion. If your transaction or your durable execution consists of 5 steps, then after the first step, you're potentially in an intermediary inconsistent state. After the second, after the third, after the fourth, and only after the 5 are you once again in a consistent state, right? Potentially. So now correctness requires completeness. It's not enough, right? It's not enough to just be complete in order to be correct, but it's a big chunk. So, and it's definitely necessary. So, and that's captured as atomicity, right? And atomicity has two two different possible interpretations. One is that it runs all or nothing, right? That is failure atomicity. Or it runs 5 executions as if it was 1 execution, right? That is this indivisible interpretation of atomicity. Databases captures that as isolation. Right? So, well, in durable executions, we can provide you isolation because we don't own all of these target systems, right? If you use a durable execution to make a bunch of service calls, we don't own the downstream systems, right? So if we change the state of one system, but not the state in the second system yet, right? We cannot pretend to be isolated. So that's or not pretend, but we can't be isolated. It's very difficult. So let's hone in on that failure atomicity, right? Where say we run to completion or not at all, right? All or nothing. Oh man, databases, they have an advantage here, a big advantage. Why? It's actually very simple. Very simple to point out why the database has a massive advantage. And this is twofold. The first one, a database transaction isn't a sequence of arbitrary operations. A database transaction is a sequence of reads and writes. All right. And the thing is, I know the semantic of reads and writes. Number one, read doesn't change the state. And number two, write changes the state. And I know exactly how it changes the state. Right. Let's say I have a database consisting of, we're now interested in a transaction, 2 database objects, X and Y, right? And X at the start of the transaction is 3 and Y at the start of the transaction is 4. If I now say X is 5 and Y is 7, I know the semantic of that right? So, and also very importantly, I know how to undo what I just did. If I set X to 5, right? I can already, like in the back of my head, basically on a journal or write a hit log, I can write a compensating action, meaning I can say set X back to 3. Right? So now, if I go through the transaction, I set X from 3 to 5, and then I crash, meaning I abort the transaction. On the recovery path, I can now look into the compensations, set X back to 3, right? And therefore I undid what I just have done. And the database is in the same state as if the transaction didn't run at all, right? So the biggest part is we know the semantic of the operations, and we can automatically already collect the necessary operations to bring the database back to the original state, therefore guaranteeing the not at all semantics, right? This is like completely or not at all. We can do that on a platform level. We don't need your cooperation for that, all right? Database does that. It doesn't matter what the developer writes in their transactions. Right. Absolutely not important. We don't have that luxury in durable executions. We just call a service. What's the semantic of the service? I don't know. This is like, what's the semantic? It's like I'm calling a generic function that is basically like reserve hotel room or book hotel room, book flight, right? Yeah, you don't know what's it's changing on the other side, right? You don't know what's happening. Not even little, right? I have absolutely no clue. Yeah. And I cannot like generically like register compensations for that, right? It's not happening. So I need the cooperation of the developer, right? And it's like the best we can do is ask the developer for every step that we are taking to register a compensating action. But also keep in the back of your head, we don't even know that a compensating action is a compensating action. But on a platform level, it's just another action. Right? So it's like, it's just something to do. on a platform. So
It would have to
best we can do.
track the changes that were made and make doing an intelligent change to compensate. Basically, like there's a lot of
Nope. Nope, that happens in your head. Yeah, you're right though. In your head, that's true. But on an application level, all we know is we call it function X.
Right.
Yeah? And then the developer registers function Y. Right?
Yeah.
That's it.
To compensate.
We don't know what X is. We don't know what Y is.
Yeah.
But you're right. As a developer, that's where we need your cooperation. You have that in your head. And X is book hotel room and Y is cancel hotel room. And we are hoping for the best. All right. We're basically just hoping that canceling that hotel room will undo whatever we just did. If that's not true, there's nothing we can do about it. Okay, so that's number one. Big advantage database. But there's one more thing, and they go hand in hand. Super, super important. So the database crashes in the middle of a transaction, right, and is now in an inconsistent state. How are we always saying that a database is never in a consistent state, in an inconsistent state? A database transitions from a consistent state to a consistent state. We say that, right? But it's not true. So not even a little bit, right? If I have 5 steps in a transaction, the database transitions from consistent state, inconsistent, 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 inconsistent to consistent, right? So if it crashes, it is in an inconsistent state. No if, else, or but. It is currently in an inconsistent state. Huh? Why do we keep saying that a database is never in an inconsistent state? Because the database does not externalize an inconsistent state. Externally observable are only consistent states. So if the database crashes and then starts, it will not answer a single query. It won't until it successfully runs through recovery. If it turns out that the database cannot run through recovery, it will refuse to answer any of your queries, no read, no write, because it can't guarantee that the answer that you get is consistent to its state before that transaction. It can, right? Therefore, it refuses to answer. It refuses to externalize its state, making the inconsistent state unobservable forever until a human operator comes in and fixes whatever needs to be fixed. So this refusal of externalization, right, is a big part of what makes transactions correct, overall correct. Because now the database goes through recovery until it goes from bad to good, and then it starts again. All right. So now let's compare that to durable executions. So first off, we already figured out that this whole Saga compensation angle is hey, best effort, if so, and it's like requires the developer's cooperation. Nothing we can do about it. Mm-hmm. All right. Now we had 5 steps. We crashed after 3. Now we have to execute 3 compensate. What if we can't? What if we cannot execute these compensations? One of the compensation keeps failing. Now what? What are we going to do? Remember the database? The recovery kept failing. The database didn't do nothing. You send a query to it. It said, not now. All right? I'm not in the right state of mind to answer your query. Once again, there's nothing we can do about it. That durable execution is now in a state where it keeps retrying until it runs out the retry budget. One of these compensations, the compensation never goes through. The system as a whole does not refuse to externalize its state. It is in an inconsistent state. All right? I have no booking in the system because we just canceled that. The flight is already canceled, but the hotel is not. Right? And there's no way to not externalize that.
Right.
That money is gone from your credit card. That hotel room is booked in the hotel system. If you call the hotel and ask if you have a reservation, the hotel will say yes.
That happened to me when I was recently this fall. My wife and I went on a cruise, and I went to go book one of the side expeditions or whatever, and totally I'm pretty sure my credit card it went through the whole process, and I received this error, and it was like, we're charging your credit card, and then it just hung, and was like super unclear. Finally, I got a notification my card was charged, but then like the booking never showed up, and I had to like call into support, and then they're like, oh yeah, you did pay for it, and then they added it back. It was a pain in the butt.
And that is exactly why, because it's not a transaction, right? So it's like the transaction would refuse to externalize any inconsistencies. But if you have like an orchestration problem where multiple systems are involved, one is in that state, one is in that state, both of them are in a consistent state for themselves, right? But in combination, they're in an inconsistent state, and then we are the ones dealing with it. Mm-hmm. And I had a similar experience with an airline where booking a flight ran into errors and continuous retries, and my credit card got charged multiple times. And the flight is not cheap, right? So it's like the credit card got charged multiple times. So obviously I called in, and them saying, don't worry about it. Yeah? So we run, yes, we see it. The ticket is only issued once, and these charges will disappear within 24 hours because we run cleanups, basically, right? So it's like they fix it after the fact. I was like, I mean, hey, I was like, luckily it was not like exceeding the credit limit, but that has real consequences, right? So at that point, it was fine.
Yeah, but it's also an interesting example of how people go and attempt to solve these issues, right? There's lots of ways, but that's one of them. Like, wait till all the disaster happens, let it ride,
yeah, and then clean up,
and then we'll go clean it up after.
Yes, absolutely. Which also is one of my greatest learnings. Retries are your friends, but also your enemies. Yeah? So it's like retries are frenemies.
Yeah.
With retries, you can achieve forward recovery, right? You fail somewhere in the middle, and then you retry that, and then you run to completeness. But if that is not done perfectly to the T, then you also run into the issue that you may have forward and recovered and achieved completeness, but still not correctness, because retry itself is what introduced the incorrect behavior.
Yep. That's a pain.
So then as a summary, right, we can look at like, okay, database transaction, absolutely fantastic developer experience. It's like, for me, unmatched, because as soon as you cross the threshold to begin transaction, right, you live worry-free. It's incredible. It's an incredible developer experience. Now we want to replicate that for distributed systems. Turns out to that level, we cannot, right? But that doesn't mean that we stop trying to get as close as possible, right? So for me, basically, a transaction sets a gold standard. I have not seen like another abstraction that has an equal appeal. But again, it's a bit of personal taste, but that has an equal appeal. And that's basically our gold standard that we strive for when we implement distributed async await. But it does turn out that there is like, in order to give you guarantees, in order to give you, for example, completeness guarantees, right? Correctness guarantees, there is a lot of ifs involved, right? So it's like, we need your cooperation. We need a lot of prerequisites that you as a developer and as an operator, you have to meet, right? So, for example, we rely on progress. Database transactions don't really, because they, again, don't externalize, right? If you pull the plug of a database system in the middle of a transaction, never plug it back in, database is fine. You cannot ask it another question. It will never externalize an inconsistent state. The last state that it externalized was perfectly consistent. Thumbs up. All safety guarantees completely achieved. Yeah? Now, with the durable executions, we say, hey, we guarantee to run you to completion, right? There's a lot of ifs in there. If I pull that plug, nope, right? So I say, if I pull the plug and never put it back in, we won't. And it's like, oh, but then it's just the same with the database transaction. Because now the system as a whole is possibly in an inconsistent state, right? The service A is in a consistent state in and of itself because it makes sure of that. Service B is in a consistent state in and of itself because it makes sure of that. But as a whole, A reflects something that B does not. So you're in an inconsistent state. And thanks to you never putting in the plug, that's not going to be resolved, right? So we rely on your cooperation as a developer and an operator to meet a lot of, like, to check a lot of checkboxes, and then we can give you completeness guarantees, right? But only then.